Okay, let's move on to the conclusion and introduce our next steps. Today, we gave this tutorial to help you model distributed training systems with ASTRA-sim. Considering that the size of machine learning models keep increasing and co-designing hardware and software is critical, ASTRA-sim is the best option for designing a training system. This diagram presents the ASTRA-sim features grouped by each layer. The features available right now are presented in green, and the features actively implemented now are presented in red. First, the workload layer offers various parallelization strategies such as data parallel, model parallel, and hybrid parallel. Second, the system layer can model ring-based, tree-based, auto-based collective communication primitives and various scheduling policies. Third, the network layer provides several backends such as analytical with congestion, Garnet, and NS3. Let me introduce our latest enhancement, graph-based execution engine in the workload layer. Currently, the workload layer accepts text-based inputs, which means that models are described in text files. We are replacing the text-based workload layer with a graph-based execution engine. The advantage of the text-based workload layer is user-friendliness. It is easy to write, and text files are human-readable. However, the limitation of text-based ASTRA-sim is its limited expressiveness. The text-based workload layer cannot model complex training loops such as pipeline parallelism. As a solution, we propose execution graph-based ASTRA-sim. We define a new graph format, ASTRA-sim execution graph, to present the execution of machine learning tasks. The execution graphs encode critical information such as computational load, communication type, communication size, and their dependencies. Execution graphs are generated by machine learning frameworks, and the execution graphs are passed to ASTRA-sim as inputs. These execution graphs can express any type of parallelisms, such as data parallelism, model parallelism, and pipeline parallelism. One might think that generating execution graphs from machine learning frameworks can be challenging. Actually, many machine learning frameworks use graphs for internal presentation. Moreover, the community actively supports generating execution graphs. The upper screenshot presents the merged pull request that adds a feature to dump execution graphs in PyTorch. As you can see on the left, less than 10 lines of code are enough to generate execution graphs. Moreover, we provide a converter to convert execution graphs in any format into a common execution graph format called ASTRA-sim execution graph. Additionally, the converter supports conversion from text-based inputs to ASTRA-sim execution graphs. Now, let's move on to the new features in the network layer. Let me introduce the currently available network backends first. First, the analytical network backend is the fastest backend because of its simplicity in its performance model. With this network backend, you can model hierarchical networks. While this network backend has an advantage in its simulation speed, it works only for congestionless network. Second, the Garnet network backend is modeled with credit-based flow control. Therefore, it is more accurate and it is useful for modeling chimlet-based architectures. There are two types of new network backends that we are working on. The first is the analytical network model with congestion modeling. As I mentioned before, the current analytical model becomes inaccurate when there is congestion. The new analytical model can achieve high accuracy by modeling congestion in networks. The second is NS3 support. This network backend allows us to model LDMA over a converged network. And it supports several congestion control schemes, such as DCQCN, ACPCC, Timely, and so on. Please check out our latest paper about the impact of rocky congestion policies on distributed training of TNNs. These new features will be released soon. Please reach out to us for early access. This is all for this tutorial. Thank you for attending this tutorial. ASTRA-sim is open source. Please feel free to raise any issues and contribute via pull request.